Hello.
Sir, good morning, sir.
Good morning, sir.
Good morning. Good morning. Okay. Is clear? Is audible?
Yes, sir.
Okay. So, but yesterday we discussed the Anthocera and Markantia. Now, today we discuss the Funaria. Okay. So, this Funaria is come from the Bryophyta. You know that one. Bryophyta. The division is the Bryophyta. The class Bryopsida. The order is Funerales. The family Funariaceae. The genus is the Funaria. Okay. So here, these Funaria plant is very advanced. Okay. Then compared to remaining bryophyte plant. Means here some leaf-like structures are there. The plant, the gametophytic plant, approximately here 1 to 5 centimeters in height. Then, which is morphologically is differentiated, means the stem, rhizoids, and the leaf. Some elevation is means the elevation character is there compared to the remaining Markantia and Anthocera. Okay, some characters are there. Rhizoids, stem, and some leaves. Sessile leaves are there. Okay, so this adult plant is differentiated into rhizoids, stem, and leaf. So here the stem is branched monopodially. Monopodially means dichotomously means the each branch again divide into two. But here monopodially means monocotomously or monopodially means only one branch will arise. Okay. The rhizoids are present at the base of the stem. In the below part of the stem, some rhizoids are grows and to attach to the substratum, means the wet area or moist soil. They are the branch and thread-like and multicellular with obligative septa. Okay. So what? Okay, is not here. Hello, is here? Hello. We use the headphone only. I use all daily. I use the headphone. Is it clear?
Yes, sir. Okay, sir.
Okay. So the rhizoids are branched. Some multicellular and septa is present. They are brown to pink in color, but the exposure at light develop chlorophyll, which are turned into green. The chlorophyll is there, so that's why they are turned into the green color. The leaves are very small and spirally arranged on the stem. See here, the leaves, okay, very small in structure. There is no stalk, means sessile, directly attached to the stem. Very small in structure. They are green in color. So a distinct midrib is there in the middle of the leaf. A distinct midrib is there. They are the sessile with a broad base and ovate in the shape. Okay. So here, this is the leaf structure. And the central is the midrib is there. So what happened here in the transverse section of the stem here, show it is the spherical in structure. The outer layer is the spherical in structure, that is the epidermis, middle cortex, and the central region is cylindrical. Central core is there. So the epidermis is the protective layer. Outer layer is the epidermis that we call as the protective layer, which is the single layer. Epidermis is a single layer and very thin cell wall and compactly arranged with the chloroplast. So some cuticula and stomata are absent. In the second region is the below the epidermis is the cortex is present. That cortex is the multi-layer, thin-walled parenchyma tissue. Okay, the central cylinder is consist of the compactly arranged with the slightly thin wall cells. So this is vertically elongated with the smaller diameter. Okay, so these central cylinder which is helps in the transport the water and minerals. Okay. The internally, the leaf has several celled thick midribs present, and the which one called as wing on either side, means both sides a wing like just are there, just like this one. The cells of the wings is contain chloroplast, and these chloroplast is repeated divide in the center of the midrib. The central strand is present. So this is two wings are like this structures are there. Transverse section of the leaf. Okay, like this structure. So in the centrally, the midrib is present. This midrib is to transfer mainly function as a conductive tissue. The next one is the reproduction. Okay. Hmm. Hmm. Okay. So the next one is the reproduction. So in the reproduction of the here funaria, here so we already yesterday we discussed that one, the like the Markantia and Anthoceras. Here also the vegetative and the sexual reproduction, two methods are there. Okay, two methods are there. Here vegetative reproduction. The vegetative reproduction takes place by the means of here primary and secondary protonema or gametes, death of the older parts, that is the means here, which is the breakdown of the thallus means gametophyte. A spore on the germination produces the primary protonema, which is the possess the several bulbs. Okay, several means buds layer, and that is the bulbous. Each these bird develop into the adult gametophyte. The protonema, which is developed from the part of the gametophyte plant, are called as the secondary protonema, which is developed into a new gametophytic plant body. Okay, so the next one is the sexual reproduction. Here, this is the cluster of Antheridia and Arcogonia are produced on the male and female branches of the same plant, same gametophytic plant body. In the yesterday we discussed the Anthoceras and Marcontia, but here only the single Antheridia, either Archegonia is present, but here in the Funaria, the cluster, a group of the organs are present in the same plant. Okay, the main shoot bear the Antheridia, the lateral branches bear the Archegonia. Okay, So here, the main axis bears the antheridia and lateral branches bear the archegonia. Antheridia means the male reproductive organ. Here, archegonia means the female reproductive organ. The antheridia are the clavate with the mass stalk. Okay, the capitated, the paraphysis, and sterile structure are the intermixed with the antheridia. Some paraphysis and sterile structure means a leaf-like structures are there, okay, between the antheridia. Paraphysis is also sterile filaments-like structure. And the maturity of the anthrozoids which are liberated at the pore of the antheridium. Okay, so this is the antheridia. This one, G diagram is the antheridia. So this antheridia is one stalk is there, and these are the anthrozoids, biflagellate anthrozoids are there. Okay, so the archegonia, this is the flask-like structure and long neck is present. The archegonial stalk is longer than the antheridial stalk, very long. The venture close the ventral canal cells and egg. In the neck here, the number of neck canal cells are there, means around 6 to or 8 neck canal cells are there. This is the long neck is present, this one. Okay. Both the antheridia and Cuboria are enclosed in a whole perigonal or pericytial leaf. These also sessile means sterile leaves. And maturity, the neck canal cells is designated and form the mucilaginous mass. The apical cell of the archegonial neck get separated. Anthrozoids are attracted to archegonia which are trim and fused with the egg. Ah, చూద్దామా? అబ్బా, చెప్పు అమ్మకి చెప్పు డోర్ తీసి చెప్పు లేదా బాత్రూంలో చూడు. ఆ, so after the fertilization, so here they are the to form the sporophyte. So these after fertilization, the zygote is enlarges and recreates the wall around the sporophyte. It is divided and transfers into two cells. In both the cells is obligate and interesting wall are lead to down the two faced apical cells. The upper apical cell by the result gives rise to the capsule and upper part of the theta. The cells is produced from the lower apical cells to form the lower part of the theta and foot. This is the foot and theta. This one. So here, this sporophyte of the funaria is very complex structure is there. A matches sporophyte has the basal foot and thin elongated theta and intermediate in the appear shaped, that is the pear shaped structure is the capsule is there. Foot is the conical and the small absorb nutrition and water from the gametophyte, which is the theta is long and twisted and raised the capsule above the gametophyte. It is the middle conducting stand surrounded by the cortex and epidermis. This funaria just like a urn shaped structure. urn-shaped structure. This is the capsule is differentiated into two basal, the swallow that is the apophysis and middle theca, and the apical cap-like structure that is the operculum. Apophysis, theca, and operculum. So the theta is the apical force is expanded to the apophysis. Apophysis is also sterile one. The cells has chloroplast, epidermis has stomata, and central conducting the stand that is into the apophysis. So here, the below the hypodermis, the chlorenchyma is there. That is the air cavities, and between the air cavities, the air chambers are divided by the tubercle. The columella is the central part of the theca. The one columella is this one is also sterile one, and the surrounding the columella is the barrel-shaped spore sacs are there. The spore mother cells is present in the spore sac, undergoes to the meiosis to form the haploid spore tetrad, which are developed into the spores. Okay. The each spore has an outer wall which are exosporium, and inner one is the endosporium. A nucleus oil is there, and globulus and chloroplast also present in each spore. The apical part of the capsule is consists a operculum, and the peristome is there. So here the apical region of the this one. Okay. This one is operculum and peristome are present. The operculum is the 4 to 5 layer is thick, and just beneath the operculum is a peristome is present. So here a peristome has two rows of 16 incurved triangular teeth is present. The outer teeth are red in color and inner one are colorless. The inner teeth are short than the outer ones. So mainly these peristomes are to involved in the dispersal of the spores or dehiscence of the spores. Okay. So the next one is the dehiscence of the spores. As the capsule, the mature of the cells of the columella, operculum, and the base of the annulus and other thin wall tissues of the capsule, they are the lose their water and stink. So as a result, this one is rupture and the annulus of the operculum, and so the operculum is detached the hygroscopic peristome teeth, which is help away for the operculum and also helps in the spore uh, dehiscence. Okay, so the theta is also hygroscopic structure is there in dry condition. It get twisted, and in wet in condition it was untwisted the helps in the spore dispersal. Okay, so the usually the spores are undergoes to some resting period. They are available means viable around 16 years. They are existed, but under the favorable conditions, they are the germinate within the few days. The outer wall of the sporoderm means the spore which is rupture and to develop the protonym. They are give to means protonym means a multicellular a filament like structure that is the primary protonym. So these primary protonym again differentiate into chloronema and birds and rhizoids. After some lateral branches are erased, they are to differentiate into star, stem and leaves like structure. See here, this is the life cycle of the means sorry. This is the life cycle of the funaria. Okay. After here, spores are released and germinated to give the protonema and they developed as a gametophyte. These gametophyte here have the antheridial branches in the apical stem and lateral branches they are having the archegonial stem. The antheridia is liberated, that is the anthrozoites means biflagellar anthrozoites. Are there. The archegonia is having the egg, a flask-like structures. Okay, okay, a flask-like structures are there. So long neck is there, neck canal cells are there, and the venture is there. In the venture here, egg cells are there. After liberation of these anthrozoids and fuse with the egg to form the zygote. The zygote again to develop as the sporophyte. This is the sporophyte of the female. Okay, the sporophyte means the capsule, nothing but we call as a capsule. This capsule here, theca is there, then peristomes and the periculum is present, and seta is also there, hypophysis is also there. The theca means the centralized columella. They are have the both sides of the spore sac, means sporogenous mother cells are the sporogenous mother cells to undergoes to meiosis to produce the four haploid spores are. So that each spore is a spherical in structure, then completely development of these spores and liberated with help of the operculum and peristome. So peristome teeth is have the hygroscopic nature. So that's why they lose their water and they are immediately they extend the spores and release it to the spores into the atmosphere and they are to deposit it on the substratum. They are to germinate and give rise to the a protonema means a primary protonema that is a multicellular filament like structure. That one we call as the primary protonema. After primary protonema, then laterally developed a multicellular branched and filament like structure and projected a erect stem and appear on the leaves, small sessile leaves are there. This is the structure and reproduction of the and capital structure of the funaria. Okay.
Yes, sir.
Okay. So the next topic is we are going evolution of the sporophyte in bryophytes. Okay. So here the evolution of sporophyte in bryophyte here the mainly two theories are there. Two theories. So Bower is proposed the theory of the sterilization. So means the structure of the sporophyte here, the complex structure to simple structure. Which one is the simple? Which one is the complex? Based on their structure, the Bower is to develop a theory. The theory we call as the theory of the sterilization. And another theory we call as the reduction theory. Theory of the reduction and the theory of the sterilization or theory of the progressive uh, sterilization. So here means according to the Bower, what happened here? The series of the sporophyte of the bryophyte show the natural advanced in the progressive elaboration and complexity. So here the progressive sterilization of the potentially fertile cells instead of forming the spores for propagative purpose they remain sterile. Means here the fertile cells are progressive. Okay, to increase the fertile cells These sterile cells take the function of nutritive dehiscence and dispersal. This hypothesis, Bowen, is known as the theory of the sterilization. Okay, clear? Hello? Hello.
Yes, sir.
Yes, sir.
So, so this theory we call as the progress means sterilization theory. It explains the evolution of the sporophyte and bryophyte on the basis of the progressive elaboration and complexity of the sporophyte. Means structure of the complexity. The other supports of this theory means Campbell and Smith is also proposed. So here we see the different types of the uh, Rixia and Markantia and Anthocyrus and Funaria. So different structures are there. We see this one. So based on the structure of the sporophyte is differentiated from Rixia onwards to Funaria. The complex structure is there, complexity structure is developed. So, for example, in Rixia, sporophyte of the Rixia, we see this one. The top one is the Rixia sporophyte. This one is clear. Are you visible? Hello, hello.
Yes, sir.
Okay. So the zygote after fertilization increase in the size and undergoes to a single division from the two-cell embryo. This embryo by the repeated division to form around 20 to 30 undifferentiated cells which will later on the differentiation to outer sterile cells, that is the amphithecium, and inner mass of the fertile sporogenous cell. That one we call as the endothecium. Outer one we call as the amphithecium, and that one is the sterile one, and inner one is the fertile cell, that is the endothecium. So here amphithecium forms a single layer capsule wall, and endothecium became the archisporium and potentially spore mother cells and to produce the spores. So sometimes in the abortive nutrition cells also there, that one we call as the elater. So in the Rixia, there is no food theta. There is no food and theta in the Rixia. So very little sterilization of the potentially fertile. Okay, clear? Sterile cells are very little one, but the more potentially the region is only fertile cell. Okay. The next one means which is act as only spore producing organ in Rixia, amphithecium and endothecium. Two parts are there. Endothecium is only cover the outer one. The amphithecium only to develop as the cover layer. Endothecium to develop as a sporogenous tissue. The sporogenous tissue means spore mother cells undergoes to meiosis. The spore tetrads will there. Here means the sterile cells are very less. Only the fertile cells are more. The next one is the Markantia. This is the Markantia. Here there is no foot and seta, only capsule is there, spherical capsule is there. But here in Markantia, we are differentiating into foot, seta, and capsule, elongated capsule is there. Okay. In the Markantia, the two-celled embryo divide at right angle and four-cell embryo is formed. The two lowermost cells called hypobasal cells remain sterile and form the foot and theta. Lower one to form the foot and theta, which is the sterile. The upper two cells called as the epibasal cells, The cells are called as the fertile cells by the repeated division to form the upper part of the fruit and theta and capsule. The capsule, the capsule portion is differentiated into and epithelium and endothelium. The single layer capsular wall is formed from the epithelium. The outermost layer we call as the epithelium, that is the protective layer. The entire mass of the endothelium act as a sporogenous tissue became the archisporium. Epithelium and endothelium here also. So here the archisporium remains the sterile cells or the elongated development stage, while the thick and broad became some structures are there. Okay. Okay. Some elaters also there. These elaters are hygroscopic in nature is there, which is present in the please keep the mute, all of you keep the mute.
Sir, disturbance coming.
Please keep the mute, all of you mute. So here, these elaters, long spherical structures are there. That is some rod-like structures are there. This one we call as the elater. This one, a spindle-like structure. A spindle-like structures are there. This one is the elater. Okay. This one elaters are. These elaters are hygroscopic nature is there, which is involved in the pore dispersion. So, and other half of the archisporium became the spore mother cells, some of the sporogenous cells, and they are the sterile. Okay, the sterile apical cap, the apex and the spirally thick and elongated elaters are there. This is the illustrate a step to further the progress to sterilization of the sporophyte with the consequent elaboration. So some sterilization, sterilized tissues are developed gradually. So elaborated the sterilization tissue. Theory of sterilization. Similarly, see here. Then compared to Rixia, here Marconsia, some sterilization tissues are gradually developed. Okay. So coming from the Pelia, so the hypobasal cells does not take in part of the development of this sporophyte. Only the epibasal cells divide and differentiate into amphithecium and endothecium. The amphithecium to form the capsule wall and endothecium act as the archisporium. So upper part of the epibasal cell to form the capsule and lower part one, which is sterile elater. So these elaters are very long, slender with the double spiral thickenings on their walls. Some of these sterile cells became a compact and form the elatophores also. These sterile structures are involved in the pore dispersal. This sterilization process is advanced further coming efficiencies for dispersal structure. Okay. Means here from the complex means a simple structure to complex structure. The mechanism of the spore dispersal is increased. Well developed spore dispersal mechanism than compared to Rixia and Markantia and Epilia. Though coming from the Anthocera. So this is the Anthocera structure. So here in the Anthoceras, what happened here? The sporophyte of the Anthoceras here Two-celled embryo is converted into eight-cell embryo and formed arranged into two tiers of four cells each. The lower tier, okay, two tiers. Each tier here, four cells are there. The lower tier bud further division to form the mass of foot and the cells of upper tier also by repeated division to form the capsule. The capsule is the younger condition is differentiated into outer amphitheecium and inner one endothelium. The endothelium is sterile and form the central column of the sterile cells called as the columella. The middle one, this one is the columella is there, sterile slender columella is there, which is surrounding the over the archisporial top of the columella. Their sheet that one is called as the porogenous tissue, porogenous mother cell. Okay. So this archosporium, which is extremely reduced, or the archosporium form the spore mother cells and pseudovillators also. The archosporium in Anthoceras, thus the extremely reduced, it forms the narrow part of the capsule, very small structure in the capsule of Anthoceras. The covering layer of the capsule and archosporium is divided from the amphitheecium. The jacket layer is consist of the chloroplast and stomata. This enables the sporophyte to lead the independent. They are the exist. This type of the sporophyte shows a marked reduction in the sporogenous tissue due to the more sterilization tissue. So here the sterile tissue is more than compared to fertile tissue of the anthoceras. So only a between the columella, only the columella, beside the columella, only the spore mother sac, sporogenous is there. This one. Okay. The remaining all are the sterile cells are there. Means four seta and columella and parenchyma tissue, stomata and other areas. Okay. Means here also the progressive sterilization. They are elaborated the sterilization tissue. Is okay, clear mind? Are you audible? Audible?
Yes, sir.
So here, the elaborated, the sterile tissue is more than compared to fertile. So here in the Rixia, only major portion is the fertile tissue. The Markantia gradually, the sterile tissue is progress. Here also, then compared to Markantia, here the sterile tissue is progressive. The next one is the funaria. We see the funaria sporophyte. This is very complexity of the sterile cell. So the major part of the embryo sporophyte remains sterile and form the foot and theta. Major part of the here totally the sporophyte fertile cell. Total and foot and theta. The capsule of the sporophyte is developed from the epibasal cells and the foot and theta from the hypobasal cells. The epibasal cells divide and periclinally form the outer amphitheecium and inner endothelium. They are periclinally, which is the amphitheecium and endothelium. The amphitheecium became which is differentiated in the epidermis and photosynthetic tissues of the capsule wall and outer spore sac. This total is the complexity of the sterile cell. The amphithecium at the apex of the capsule form the multi-layered operculum, while the innermost portion form the peristome. The endothecium is the sterile. The thin and outermost layer form the amphithecium. The amphithecium at the apex of the capsule form the multi-layer the amphithecium at the apex of the capsule from the multi-layer operculum, while the innermost portion from the peristome. The endothecium is the sterile, and the thin outermost layer form the archisporium. So the capsule is a pear-shaped structure which is the basal cell sterile, known as apophysis. The outermost layer is the epidermal layer below the massive parenchyma cells, which is the chloroplast are present in the so here the outermost layer of the epidermal layer below the which mass is the parenchyma cells, uh, the apophysis. The outermost layer epidermal cells, which is the mass parenchyma cells, the chloroplast are present. There are the larger air space transferred the delicate strands of the parenchyma cells, that one we call as the trabeculae. So here surrounding of the lid of the capsule, a ring of the that is the cutinized epidermal cells, that one we call as annulus is present, which helps in the spore dispersal. The progressive sterilization of the potentially the sporogenous tissues increased here. They give the explain the Boyer theory sterilization of the relations prophyte in bryophyte. Okay, this is the theory of the sterilization theory. Okay, next one is the reduction theory. So here reduction theory is also there. That is the here reduction theory means here reduction theory. What is the reduction theory here? Kasha Church and Gamble and Evans is proposed this theory. So the evolution is downwards in direct the series shows in the retrogressive evolution. There is and ample evidence for this type. This reduction is compared by the simplification of the structure of the sporophyte. What is says here? Simplification structure, simple structure. On the basis of this, simplest sporophyte of Rixia is considered as highly evaluated and reduced as a result of progressive simplification. Okay, so here, what is the simple structure? Which one is the simple structure in this sporophyte? Rixia. Hello, please respond. Anybody?
Sir, yes, sir.
So Rixia is the simple structure of the sporophyte, then compared to Funaria.
Yes, sir.
So that's why the in the reduction theory is says is the Rixia is highly evaluable sporophyte. Means there is no other material, means sterile tissues are not present in the Rixia. Only the fertile cells are there. So that's why the Bowell and Evans is proposed this reduction theory based on the simplicity of the structure of the sporophyte. So that's why the Rixia is the mostly evolved structure than compared to Funaria. So they are the proposed these leaf theories are the leaves of the erect sporophyte were lost due to the intense erosion and desiccation. The erect leaf sporophyte became the attached to the gametophyte. Okay, the airspace of the photosynthetic system is disappeared due to the more dependence on the gametophyte. The stomata is first became the functionless and later on they disappeared as the mercantile Jangarmonial. So here the simplification of the dehiscence aperture is present and the reduction of the photosynthetic tissue in the capsule wall and decrease the thickness of the capsule wall with the disappearing the thickness of the wall material from the wall cell. These changes slowly eliminate foot and theta. So in Rixia, there is no foot and theta, only capsule is present. So all these changes happen for the progressive increase in the fertile of the sporogenous cells. So this evidence from the comparative morphology and experimental genetic support view the simple Rixia sporophyte is advanced than compared to Funaria. Okay, Nandi. Hello.
Okay, sir.
Mm. So what starting here? Please everyone mute on okay. Okay, clear. This is the evolution of sporophyte in bryophyte. Okay, Nandi. So what the Bower says here complexity structure is more advanced than compared to simple structure. But here the reduction theory means Evans and Bowell says the simple structure is more advanced than compared to complex structure. So that's why here in the sterilization theory, the Rixia is the simple structure and Funaria is the complex structure, Funaria is the advanced structure. But in reduction theory says the simple structure of the Rixia is highly evolved structure. Okay, so this is clear, all of you. Hello. Hmm?
Clear, sir.
Yes.
Hmm. So from here, the Funaria sporophyte structure of the sporophyte Funaria is from one question that is the important question. Structure of the sporophyte. This is important question. Another one, these evolution of sporophyte in bryophyte. This essay question is compulsory. They are asking compulsory question in essay question. Evolution of sporophyte in bryophyte. You should write your two theories: theory of sterilization and reduction theory. Two theories you should attempt with the diagrams also. With the diagrams.
Okay, sir.
This compulsory question they are asking in the examination point of theory of the evolution in sporophyte in bryophyte. Two theories: sterilization theory and reduction theory. Okay.
Okay.
So then tomorrow we discuss the tomorrow is not there. Tomorrow is there. We have the
No,
class.
no, sir. No.
Tomorrow is not there, and after tomorrow we start the pteridophyta. Okay, clear from bryophyte. From bryophyte topics, all are clear.
Yes, sir.
So here bryophytes means general characters of bryophyta. That one is important point. And the Markantia thallus, and the Archegonia antheridia, and sporophyte of the Markantia. That one is important from the Markantia. From Anthoceras, here internal structure of the thallus. Internal structure of the thallus, and similarly here Archegoniophore, antheridiophore, and sporophyte of the Anthoceras. From the funaria, only the sporophyte of the funaria, structure of the sporophyte of the funaria, that is important. Okay. Then here the third topic is the theory of two theories are the evolution of sporophyte and bryophytes. The two theories are very important. They are asking the essay question: evolution of sporophyte in bryophyte. Okay.
Okay, sir.
Okay. Any doubt? Here.
Nothing.
Nothing. Okay. Right handy. You two theories you should write. Okay. Sterilization theory and reduction theory with the diagrams. Okay, Nandi.
Okay, sir.
So based on the sterilization theory, which one is the primitive?
Yes, sir.
Based on the sterilization theory, which sporophyte is the primitive sporophyte?
Yes, sir.
Riccia.
Anybody?
Riccia, sir.
Okay, very good. So the Rixia is the simple structure is there, very primitive. Advanced one is the funaria.
Funaria.
From Markantia to funaria. Okay, Nandi. So based on the reduction theory, the Rixia is the very advanced structure then compared to funaria. Okay, this one is some important topic. Okay, Nandi. Okay.
Okay, sir.
Okay. So okay, thank you. Thank you for attending the class.
Yeah, hello again.